So graphing cube roots. So yesterday I told you that graphing a square root was kind of like graphing a parabola just on its side, right? And depending on if you had positive or negative determined what side you had of it, correct? Graphing a cube root, if you remember, a cubic looked something like that. Yes? Graphing a cube root looks like that. Okay, again, it's just on its side. So I actually think graphing cube roots is easier than graphing square roots because you don't have to worry about the plus minus thing, and that makes things in general easier. So this is the formula for it. We still have A, B, H, K. Notice B is kind of funky there. Again, we're only going to worry about horizontal reflections. We're not going to worry about stretches and compresses. Yes, B does influence, or it does create stretches and compresses horizontally, but we're not going to do those. My inflection point. Any guesses what my inflection point is? HK. Whatever H is and whatever K is. Do you think I need to change the sign of H? Yep, just like always. Easy cube roots. That should be an easy one. What's the cube root of 1? Here's another one that should be easy. Yeah? What's another one? 27. What would the next one be? Anyone know? 64, because the cube root of 64 is 4, right? You're looking for what number to the third power gets you that value. Do you remember domain and range for cubics? If you looked at my picture there, domain and range for cubics was what? All real numbers, both directions, right? Well, guess what? If I turn this onto its side, it's still all real numbers in both directions. Do you see that? So domain, ooh, I didn't do my R there right, and range are both all real numbers. Okay. All right. Let's see. One thing that's interesting about these guys is if you have a vertical reflection or a horizontal reflection, they look exactly the same. They did the same thing with cubics. Cubics, horizontal and vertical reflections looked the same. So in general, when you have a positive A and B value, meaning you have no reflection of any kind, you're going to have a graph that goes like this. And you're going to have your inflection point right in here somewhere. So your end behavior on the right is going up, and on the left is going down. Yes? If you have a negative either in the A or the B location, then you have something that looks like this. And again, your little inflection point would be somewhere in here. And the right side is now going down, the left side is going up. Okay? Now, something I told last period, whenever you're reading a graph, you always want to read it from left to right. And what I want you to think of is, I want you to think of the little stick figure here. There's a little man there, and he's going to walk from the left side of my graph to the right side of my graph. Is he going uphill or downhill? Uphill. When he is going uphill, I have positive A and B. If he is on this graph, where is he going? Downhill. That means I have negative A or B. What if I have a negative A and a negative B? If you flip it, and then you flip it again, you're back to where you started with. So a negative A and a negative B would actually give you something that looks like this. Okay? Kind of funky, but it is. And this is kind of the same with all of them. When we had weird graphs like this, still picture your little stick person walking. And even though they may go up and down periodically throughout their journey, overall, he'd be going uphill, which means I have a positive leading coefficient, or a positive A value. Okay? So that's kind of how you want to read your graph. All right, so now let's graph the mother function. You ready for that? Here's my highlighter. Mother function of all cubics. Right there. In the mother function, what is the h and k value always? 0, 0. That is my inflection point, is 0, 0. When I make my xy table, where do you think 0, 0 goes? In the middle. Okay? Now, I'm going to stretch your thinking a little bit, and I'm going to come back to these numbers right here. Those numbers. These are going to help me find the next values to put in my XY chart. Because I don't just want 5 numbers in a row with 0. I don't want to just do -2, -1, 0, 1, 2. I want to do, first off, a number 1 away on either side. So 1 away from 0 would be -1 and +1. Yes? The next numbers I want to do are 8 away from 0. So 8 on the negative side would be -8. 8 on the positive side would be +8. Why do I want to use those? Because these are numbers I know will make a nice cube root. You can take the cube root of easily. I could do 2 and -2 and just do -2, -1, 0, 1, 2. But 2 and -2, I'm going to have to go to my calculator because I can't take the cube root of 2 very easily. Do you get that? So it's easiest if I go 1 out and then I go 8 out. That's the same reason why on the squared notes yesterday, you went 1 out and then you went 4 out. Because what are your good square roots? 1, next one is 4. Next one would be 9. These are the numbers that you wanted to go out, or how far you wanted to go out, I should say. So, let's see what this does. What's the cube root of -8? -2. What's the cube root of -1? What's the cube root of 1? Cube root of 8? Let's plot our points. -8. 2, 3, 4, 5, 6, 7, 8. -2. -1, -1, 0, 0, 1, 1, and 8, 2. And that's what my cubic looks like. Would my little stick figure be walking uphill or downhill? Uphill. As he walks from left to right, he's going uphill. So what does that mean about the end behavior on the right? It's going up. The end behavior on the left is what? Negative, because it's going down. Domain and range? All real numbers. Done. Terribly difficult? The next one has my XY chart already filled out for me, doesn't it? So let's see, where's the inflection point? What's the inflection point here? -2, -4. Do you see that? And then do you see that 1 away from -2 is either -1 or -3? And then 8 away, if I do -2 plus 8, there's 6. And -2 minus 8 is -10. So it's following that same pattern. It's already graphed for me too. My goodness. Okay, so I have a point of inflection at -2, -4. Let's describe what's going on. So comparing this equation to the mother function over here, what's going on? We have a shift left 2. And that's because my h value is -2. We also have a what? A shift down 4 because I have a k value of -4. Don't have to worry about anything with a and b. There's also no reflection. So what does that mean? The end behavior is exactly the same as the mother function. Right side's still going up, left side's still going down. Domain and range, all real numbers. Pretty easy. It's just like graphing cubics, really. The only difference is how you set up your x values there. All right, let's describe this one first. What does the 1/2 mean is going on? I have a what? What kind of a compression? A vertical or a horizontal compression? Vertical compression. Of what? 1/2. And then that +3 means I have what? Shift up 3. So I'm moving the parent function 3 units up, but I'm also making it half as tall as it was. What is my point of inflection? What's my h value? 0. K is 3. That's what goes in the middle. What is 1 away from 0? -1 and +1. And then what's 8 away from 0? -8 and +8. I'm going to do this one on my calculator, just because there's a fraction involved. So I'm going to use my fraction button. You ready? 1 fraction 2 times. You ready to see how to plug in a cube root on your calculator? Now, some of you have a button that says cube root, and you just need to find it. Others of you might not, but you have a button that looks like this, and I know that's super teeny tiny to see, but it actually looks like this on my calculator. There's a little X right there. So if I want to do a cube root, what I have to do is I have to type in a 3 and then that button. And that means it'll calculate a cube root. If I put in a 4 there, it would calculate a 4th root, and so on and so forth. So let's see. If I do 3 and then that button right there, this means a cube root. And you can't see it because there's a glare right there. 3 cube root. So I have 1/2 times the cube root of, and I'm going to start off with -8. Now I'm going to add some parentheses in here actually, because I want to make sure it understands that the +3 is not a part of that cube root. Okay, everyone okay with how I typed that in? And now I'm going to hit enter. And I get 2. Could I do this in my head? Absolutely. But I don't want to have to type this in every single time. So how can I go and plug in -1 without having to clear that? Arrow to the left. Go until that 8 is blinking. Don't click delete or anything. Just type in the 1 and look, now it's a -1. Hit enter. 2.5. Uh-oh. How do I change that to a decimal? Because decimals are more reasonable to graph with. Second, and then this guy to get to that F arrow D. 2.5. Let's see, can I go back again? I can, look at that. I just arrowed up to get to that one. And change the -1 to a +1. So I want to highlight that negative sign and delete it. What do I get? 3.5. Change it to a decimal, 3.5. And again, I'm going to arrow up till I get back to my equation. I'm going to change that 1 to an 8, and I get 4. Now, I specifically chose those x values because I wanted to find numbers that were easy to take the cube root of. So why did I still get decimals? Because I have a half in front. When I have a half in front, I'm going to get decimals, but I should get decimals that are something 0.5, right? All right, so let's plot those. -8 to -1, 2.5, 0, 3, 1, 3.5, and 8, 4. So I have a super skinny one, don't I? It's a pretty skinny one. What's my end behavior? What's going on the right side? going up. Left side is going down. Domain and range, both all real numbers. Questions there? Ready for the back side? Okay. What have we got going on here? Describe. Let's see. What have we got? I see a negative sign. What there? What does that mean? What kind of reflection? It's a horizontal reflection. How do I know it's horizontal? Because it's inside the radical. A vertical reflection would be out in front of the radical. I have a horizontal reflection. What else do I have going on? A shift right. One. Anything else? Nope, that's it. What's my point of inflection? Positive 1, 0. So 1, 0. What is 1 away from 1? 2 and 0, correct? And then 8 away. 1 plus 8 is 9. 1 minus 8 is negative 7. Those are the x values I want to use. So let's see. If I have the cube root of negative parentheses, negative 7 minus 1, close parentheses, I get 2. If I go back and I change that negative 7 to a 0, I get 1. Go back and change the 0 to a 2, I get negative 1. And to a 9, I get negative 2. So if I plot those points, negative 7, 2, 0, 1, 1, 0, 2, negative 1, and 9, negative 2, my graph looks something like that. Did my end behavior change? Yes. What's going on the right side? It's going down. What's going on the left side? It's going up. Domain and range are both all real numbers. Pretty easy? All right, now for our last two problems. The last two problems are a little different. I'm giving you a graph. I want you to tell me the equation. So to write the equation, do you notice there's no b value in this equation? So I only need to find a, h, and k. What do you think is easiest to find first? H and k. How do I find h and k? I find the inflection point. Where's my inflection point? Right there. What is that point? Negative 1, negative 3. So that's my h and my k value. So far, so good? Now I need to find a. And we're going to reflect back to when we did the little box thing. Do you remember that with cubics? This is the parent function, by the way, that's graphed in here. And when you go from the inflection point to the point just next to it, and you make a box, you're always going to end up in the parent function with a box that's 1 unit by 1 unit. If I do that here, now take your inflection point. It doesn't really matter whether you use the point on the left or the point on the right. Doesn't matter. Just pick one of them. And when you make a box, that box is 1 unit wide and what? 3 units high? So what do you think that means about A? It's 3. Is it a positive 3 or is it a negative 3? If I draw my little stick figure, is he walking uphill or downhill? downhill. So what does that mean about my a value? It's negative. So now I just put it all in the equation. F of x equals negative 3 cube root of x, let's see, h is negative 1, so it's going to look like a plus 1. And then my k value has to be outside of the radical. And that's my equation. Not too bad? All right, let's look at this guy. What's my inflection point? 4, careful. 1, 2, 3, 4, 1, 2, 3. So they're counting actually every other line as 1, which means they're counting by 1/2. So this is the point 4, but that's not 2, that's actually only 1. So my inflection point is 4, 1. That's my HK. Any questions about that? Okay. So now let's find A. Is A going to be positive or negative? Positive, because my little stick figure guy, he would be walking uphill, just like in the parent function. So my A value is positive, and if I were to draw the little box, again, it doesn't matter, as long as your inflection point is one of the 2 points, it doesn't matter whether you draw it to the left or to the right. But if I look at this, it looks like it's 2 units wide, but based on the way they're counting, it's only 1 unit wide. Do you see that? How tall is it? Based on the way they're counting, that's not 1. That's 1/2. Yeah? Because it takes 2 boxes to be 1. So what's my A value? 1/2. So I'm going to plug that into my equation. G of x equals 1/2 cube root of x, that's a positive 4, so it's going to look like a minus 4, and then plus 1 at the end. Okay? Yes?
Why was the equation on the other column f of x and this one's g of x?
Don't know. This one they just said write it in f of x. This one they said write g of x, so I was just following what they gave me. Okay? Any other questions? All right. Happy studying.